Hey there, welcome to another edition of Kung Fu Physics, and I have another mechanics problem for you today. I'm in a bit of a pickle as to how to present this one exactly because I just don't know what to say about it. We'll get it up here and read it, and we'll talk about it. It's number 8. This would be on the 1992 exam. It looks like this. Okay, so it's got a diagram. As usual, I'm looking at answers first. Let's go right into it. I look at answers first, and it looks a little complicated, giving me some type of force, looks like, and a point. A lot of negative signs to keep track of. Let's read the problem. Number 8, a solid cone hangs from a frictionless pivot at the origin 0 or O as shown above. If the unit vectors I, J, and K are unit vectors and A, B, and C are positive constants, which of the following forces F applied to the rim of the cone at a point P results in a torque tau on the cone with a negative component tau sub Z? So, I don't know how to explain this. The way that I did the problem, I did this just a few minutes ago for the first time. I don't know that I wasn't timing myself. Did I solve it in under 2 minutes? Probably not. It wasn't too much over. But the way that I solved it is just using the right hand rule. And I just went through each of those answers, and then when I found one that was pointing, that had a component pointing in the negative Z direction, I double checked it, and I picked that answer. So the right hand rule, and that and this, I think, is all you need to solve this. The torque equals R cross F. Don't get that confused. Don't get it the other way around. But torque equals R cross F. And so on all of these, I just went through and imagine I'm doing this whole thing. I'm imagining there's R. And then, okay, which way is the force here? Oh, okay. And then, so the torque is pointing where my thumb points. I don't know how you learned the right-hand rule, but that's how I learned the right-hand rule. You take the first vector and place your fingers along the first vector of your right hand. Don't use your left. And then you curl the vector towards the second vector that you're crossing it with. And the thumb is going to point in the direction of the cross product, right? That's one of the right-hand rules that physicists learn. I guess there's others for currents and crap. But that's how I did it. So I went through and just eliminated it. And if my thumb was pointing in general up somewhere along the z-axis in an upwards direction, I said, that's not it, that's not it. And then I got to the third answer, and I thought, oh, I think maybe this is it. So I guess what I can do is maybe diagram out the third answer a little bit and just kind of show you how that is. Now, I'm quite certain that if you are a lot smarter than I am, maybe you can do the math, and the math pops out at you immediately, and you are seeing the cross products in your head and doing the math, and you can just say, oh, I see where the Z is negative by the cross product. I can do cross products just as good as the next guy, but I can't do them fast, and I can't do them in under 2 minutes. So for me, it's the right hand rule. But if you got a better way to do it, then by all means run with it. So in answer C, here's my coordinate axis that I've drawn in. I'm not even going to draw in the cone because it'll just muddle things up, right? The point P in answer C is located at negative B. So we go back. And then this is a distance, well, 0, B, 0 there. And then 0 in the J direction, and a negative C, so it goes down this way. And so that's this point. This point is negative B, 0. negative c. Totally messed that up here. This is negative b, 0, 0 at that point. Anyways, so the vector, I'm kind of imagining in my head, is going down that way for, this is my r vector. And then the force that we're going to cross that with is some a in the j direction. So my force is just going to lie along here. That's my force vector. And so, I don't know, can you see it? I mean, I could use pencils or markers and stuff too to try it. I don't think I have enough hands though. But I mean, can you see it? I'm kind of pushing down and back for that first vector. And then my force vector is up here, and so as I cross with that, I come up and my thumb's going down. It's going down in the z direction. I don't know. I wish I could give you better than that. Maybe I'll be frustrated with this video, and maybe at some point I'll come back and write out the components and crap like that. But that's how I did the problem. I did that a lot faster, of course. I did it in my head, but I was kind of using my hand, and I don't give a crap if I'm sitting in the physics GRE doing this with my hand while I'm trying to work out a problem and get it right and do it fast. People may look at me funny. They're taking the test around me, but in all honesty, they're probably busy doing their own stuff. So yeah, that's how I did it. Right hand rule, torque equals R cross F, and process of elimination. That's that for number 8 off of the 92 exam. Thanks for watching.